Now, my plan for today has several components, which are not necessarily all compatible with the time frame that we have allotted to us. Okay, so the first and foremost priorities, because I had promised it as part of discussion with some of you, is to discuss some of the basics of functions and closures in Scala, and particularly the use of these higher order functions, so-called higher order functions that we explored last time, to wit, map, filter, group by, and reduce. Okay, so that's my foremost goal, and it's to that I will press myself most assiduously. The second goal will be to see if I can answer questions that come out of the take-home exercise. Okay. The third goal would be to see if I can address questions that come out of the reading. And I'd ask you to rest assured that if I can't incorporate each such goal into today's discussion, I will make every attempt to do so next time. Okay? So just a comment on the exercise. You can see I've been active in my my Scala sort of explorations here. Note that Scala shell does remember, even after you quit it, it remembers your earlier commands. Does not necessarily remember the variables that came out of that. It's not like it persists all the data that came out, but the history is maintained, and so you can go back to earlier history. In the take-home exercise, I asked for two components. One is where we go and open up a document. Anyone recognize what this document is? It's Dylan's master thesis. That's right.
Well, you just open up and it's pretty obvious.
Yeah, so he might be chuffed to hear we're examining it with Scala. He's a Scala fan. So we open.
Is that a good thing or a bad thing?
It's a good thing.
Okay.
It means he's sort of, in Australian parlance, it means he's fired up and sort of invigorated and excited by that. Okay. So I asked that you open up this document and you divide it up into words, and then you go and for each of those words keep track of how many instances of that word there were in the document. That was one task, and another task involved you counting the number of words of a certain size, right? So keeping track of how many words there were of a certain number of characters. One character, two character, one character like a, two characters like of, or what other two character words are there? It, be, two,
I-O.
I-O, okay, good. Three, the, four, etc. Right?
So when you say that you want 2 letter words or 2 character tokens?
Two character tokens is a fair way to characterize it more technically.
Well,
It's delineated by spaces, but I think I gave you those constraints. So I actually specified something that basically separated things out according to any non-alphabetic character was considered as sort of separating the two things around it.
So if you have something that was like I/O for I-O.
Yes, it would separate into I and O.
Okay.
Yes, indeed. Briefly speaking, what I did is I created a pipeline here, which performed this. This was based on our earlier explorations. And today we are going to go through and explore the meaning more closely of some of these components. But what happened is I read in that document, I turned it into lines. This getLines actually returns an iterator in Scala, meaning it's actually not a full collection. It has the ability to kind of go through and iterate through and list each line when you ask it to. And then we converted that to a stream. And why a stream? Well, ladies and gentlemen, a stream allows us to process this without keeping the whole document in memory for successive sort of intermediate steps. So if we hadn't converted to a stream, we could have in fact cut that out. We could have eliminated this toStream, but the semantics of it would be very different. And we're going to talk about that more likely next time. But if I had eliminated this toStream, what would have happened is we would have got the lines, obtained the lines, we would then split the lines here, and so we split them up into tokens, into contiguous series of alphabetic characters. We would then, and that split would yield a big data structure, a huge data structure of separate tokens, okay, across the entire document. And then for each of those tokens, it would go through and it would determine, okay, is the length, for this one, is the length of that token greater than 0? That's this little element here. And out of that would come a new data structure, listing all the words whose length is greater than 0, right? This is without the toStream. Coming out of that, just like that, indeed. Coming out of that, it would then take each of those words. So where could someone pass me the pen down there? Yonder pen. Thank you. Okay, so here we have the lines obtained, and then it's going to have a bunch of but those lines are individually going to be placed into individual tokens. You know, this thesis, you know, is mine or whatever, right? Okay. So there's a bunch of words, and then some of these words are actually empty. There's nothing. There ain't nothing there. Okay, and this filter step basically is going to, you know, that thesis is yours or something. The filter step is going to yield, without stream, the filter step will yield a new collection that is going to have included most of these, but some will be eliminated. This one, which is empty, ain't nothing there. There's an empty string. That's eliminated. And yeah, but these will go, will sort of be retained, okay? So this would have produced a big data structure after we do the filter. And then after that, we're going to be doing this mapping, okay? Here we're mapping each of these to lowercase. So we're getting a lowercase from a capital THIS. We're getting a lowercase THIS. So we're taking the token and we're making it lowercase. That's what this is, this map. Do you see that? Mm-hmm. It's performing a map in a sense of a function maps from one thing to another. It takes a value and turns it into a new value. And so these are not merely passed on, they are passed on with to a lowercase. I'll write it as kind of L. They're turned into a lowercase, right?
So the map function basically creates a mathematical transformation of your data.
Correct. Applied element-wise.
A transformation, mathematically speaking.
Yes,
okay.
That's right. Applied element-wise to the data. Okay. And we're going to be talking about map. And then what's going to happen is, having done that, if you weren't doing this in a stream, what will be happening is we'd group by. We'd create a group by. Now this is going to produce not some big list or other structure. It's going to produce a dictionary, and what the dictionary is going to have is, and if I chose my words artfully, I should have chosen buffalo, buffalo, buffalo. You know, or maybe I'll make this down here. This is going to be a structure which maps from individual keys, and here words, That's why it's saying group by a word. It's going to map from a word to a list of these tokens that are instances of that word. So there's no alas. Here we are. Okay, good. This one will go down to here because this is also the word this. So these are the two instances of this here, are these guys here. But there's going to be another entry in this, actually I said dictionary, it's a map. It's a map that has keys, these are the keys here, and so this would be thesis, and here there'd only be right now one thing that referred to it, and that's this guy here, okay? That's the token associated with that's the only value in here. So in short, this maps keys, which are the actual words, to a list of all the things that contain that word, right? And in general, there could be many instances where the word this appears in the thesis, okay? That's what's produced by group by.
Question.
Group by sort of takes all those of these that are the same, puts them in a list, and associates that with the word. Yes,
Okay.
Scott, yeah,
So,
yeah.
if I was doing this group by on sentences rather than words,
Yes.
and I wanted to do it on every word in the sentence, could I have multiple keys mapping to the same sentence?
Multiple keys mapping to the same sentence.
Like, for example,
I understand what you're saying.
Okay.
Yes, although it would involve more structure to the
Okay.
to the expression. But yes, you could have something like that. Yeah. Yeah, I'm thinking how it would be done, but I believe that could be accomplished through changing the nature of the pipeline here. Okay.
Okay, no, I'm
And-
just
Yeah, no, it's a good question. Good question, and I'd have to sit down and figure out if it could be done in this nice sort of pipelined way. Now, then there's a map values here, and what this does is it takes the same dictionary entries. So all it's doing is mapping. These are called the values. These guys here, these are called the values of the dictionary, and these are called the keys of the dictionary. Okay, or of the map. Call it a map to be more general. A dictionary is a type of map. Okay, these are the values here. And what it does is, for each of these entries, it keeps the key, but now it has performed a mathematical function on the value. So it takes this list and replaces it here by what? What does it replace? By what does it replace it?
the size of the column.
The size of it. So this is 2. This one here would be for thesis. Thesis, it will be replaced by 1. For this, whatever the next one down is it'll be replaced by 1 as well, because there's only one of them we've seen, et cetera. But in general, these will probably have lots of values because it's accumulating across. The point is, it's creating a new data structure, right? It's creating a new data structure there, and then what we're doing is I'm turning it to a sequence and I'm sorting it with it, which you don't have to worry about too much. I didn't ask you to do that. I think.
That's sorting in alphabetical
Yeah.
order.
That's sorting by the order of the number
Oh, okay.
here. Okay. And it turns out that that's going to produce an entirely new data structure yet, a sequence. Okay. Now, because I declared this as a stream, we're going to have the same thing occurring conceptually, but not in terms of the data structures. What's going to occur because it's a stream is that this guy will flow down to here until the point that this group by occurs. It'll just flow down and you'll have these successive operations performed on it, okay? So essentially it'll be mapped and then it will be used. This data structure will never actually be created because it doesn't need to be. It'll simply transform this and then use this in the next step in the group by. It'll sort of consider that word. Here, this one will then occur, and it'll be processing each line in turn without ever creating this full data structure here, okay, along the way. It'll be performing each of these in turn. And next time we're going to discuss why that is. But it makes a big difference if I declare it as a stream or not, because a lot of intermediate data structures, if it's as a stream, a lot of intermediate data structures won't need to be materialized as we see it. They won't need to be created. We just will simply process each element successively and then use its value rather than creating a whole new data structure here, a whole new data structure here, a whole new data structure. Okay. We'll sort of take it, transform it successively, consume it, and go on to the next one. Transform it, successively consume it, transform it, successfully consume it without having to create full new data structures along the way. But it's useful in thinking through this process initially to think of it as creating new data structures. Yes, Cheyenne.
Yeah, so you mean that's why it is a stream.
That's why I declared it as a stream, because I didn't want to occupy my memory with it. Now, if we were to do this, okay, it's an unhappy camper here. Let's.
Take out the word stream.
Okay, yes, but that shouldn't. Okay, I need to. Okay, map values. Oh, okay. Did I not? Why is it an unhappy camper? No value source, of course. Import Scala dot io dot. Yeah. Okay, and group by is not a member of iterator. Okay. So I'd have to convert it to
Either stream or sequence.
To sequence. Yeah. Okay. This would be an example. Okay, so. Now I have to go to the right folder. Okay, fine. CD. Okay. Sorry. CD to my USASC classes 898 scalable. There we go. CD take home exercises and then actually sorry it was in the I think it was in the data. Boom. There we go. Okay. There we go. Scala. Boom. Okay, and then import that, and let's get that in there. Okay, come on. Okay, yeah.
Plot thickens.
Okay. Yeah. So now it's going to do it as a sequence. And that's what this is a reflection of. This is a sequence. Each of these is a sequence here. Okay, we'll come to that next time, but that's how that works. Now, let's suppose that you were to want to handle this instead of keeping track of the count of times that, and by the way, the sorting at the end. We would do this way. Okay. Oh man. Okay. So it looks like it remembers the things. There we are. The sorting at the end, you would do. Sure, I'll treat it as a stream. You would do with this, and then it would sort it so the ones that were most common occurred first. That's why I have this. This thing is greater than that thing. It's going to sort it by the second element of this dictionary, which is the count. Okay. So
Is the first content word in there?
Data?
Yeah, 720 instances.
720 instances. Okay. Ladies and gentlemen, if we wanted to keep track not of the count of the number of occurrences of this token, but we wanted to keep track instead of the number of occurrences of three-letter words, how would we do this? What would we modify here?
Couldn't we group by the size of the string?
Yes, we could group by the size of the string. So instead of grouping by the word itself, which is indicated with an identity, I could have I could have written, instead of word goes to word, what that's saying is, hey, group by whatever is passed to me, group by that. I could have written identity instead. And I believe Winchell made use of that fine fine sort of variant. I could have just said identity there, but I'm going to instead map towards .size. And today we're going to see a quicker way that we could write that. So here we go. So there are 6,291 three-letter words. There's 6,093 2, 500.
45-letter word in there?
Yes, there are.
String maybe?
Maybe it's one of his professor's variable names. No, it's actually not. I don't know what it is. Superfragilistic cat.
Dylan. 5 characters.
Yeah, we'd have to go look what it is, but
So
we could.
if I wanted the maximum word length in the paper, could I just ask for the maximum value in the key set?
Say this again.
If I wanted the largest, I want the size of the largest word.
Yes.
Could I just take that and ask what the largest element?
If you wanted the size of the largest word, what you would do is you would do what? Can anyone tell me? Anyone want to anticipate? If I wanted to extract the largest word, what would I do?
Split the map into 2 lists, and then take the key list, and is there a maximum function? I mean, I know there's a function that does this in Java 8.
Okay,
I'm assuming
so
this one's
yeah,
Scala.
so what you do, it's one thing we could do is, anyone want to anticipate what I'm about to do? Sorry?
Max.
Okay, but before I do the max, I'm taking a max of something. I have to get that something. What is that something? I have to turn each word into its size. And then I could do a max of that, right? 45. 45, ladies and gentlemen. So we have these pipelines.
Quite amazing.
These pipelines successively process this data. And what I said earlier is that remarkably, by going from 2 sequence, which is creating these successive sequences in memory for creating these intermediate results, by saying toStream, it all occurs incrementally, like on a word-by-word basis, which is beautiful. We can process this thing, and by changing just small elements of the pipeline, changing it here, changing it there, we can actually get it to do very useful but different types of data processing operations. We can, on the one hand, extract the length of the word of largest size. We can get the count of words that are of that occur in the document. We could go and to get the count of words of a given size. Right? We saw that. All I have to do is change this and now I'm off to the races with that. We could alternatively avoid, we could count the number of words, occurrences of a word that occur when we do consider the capitalization. How do we do that? Suppose we want to treat the in lowercase differently with the in uppercase.
Just delete the lowercase now.
Yeah, exactly. We don't need this map to lowercase. We don't need to treat all of these words as lowercase. We don't need to canonicalize them, as we would say. We don't have to turn capital THE and lowercase THE both into the lowercase variant. Instead, we could go something like this. And here we will have case distinctions between the things, right? There's not surprisingly, a lot of the earlier ones are lowercase, but we're starting to see this here, and I would hazard a guess. Yes, here's with capitalization, it has 101 occurrences. Without capitalization, 177. In short, ladies and gentlemen, this is fairly orthogonal. By going and tweaking one place in the pipeline, another place, I can tell it to do quite different things. And by artfully choosing where in the pipeline to place a new operator, I can get it to sort of perform a different sort of computation that is still meaningful, that retains a lot of the original sort of character of the original computation, but performs a very different end. Okay? pipelines, ladies and gentlemen, pipelines in Scala. Let's go see how these are realized today. Let's go try to unpack what's going on here, because there's a lot going on in this, and I'd like to talk through it, okay? So I'm going to stop